8137. 1. Welding and straightening of turbine engine rotating airfoils does not require special equipment. 2. Welding and straightening of turbine engine rotating airfoils is commonly recommended by the manufacturer. Regarding the above statements, A. Only one is true. B. Only two is true. C. Neither one nor two is true. The correct answer is C. 1. Welding and straightening of turbine engine rotating airfoils typically requires special equipment and specialized techniques. The rotating airfoils, such as turbine blades or compressor blades, are subjected to high temperatures, stresses, and dynamic loads during engine operation. If these airfoils become damaged, distorted, or misaligned, they may need to be repaired or straightened. However, the repair processes often involve specialized welding techniques and equipment, as well as precise measurement and alignment procedures. 2. Welding and straightening of turbine engine rotating airfoils are not commonly recommended by the manufacturer. Generally, the manufacturer's recommendations for repairing damaged airfoils involve replacing the affected components rather than attempting to repair them. The high performance and critical nature of turbine engine airfoils necessitate strict quality control and adherence to precise specifications, and therefore, replacement is often the preferred approach. 8138. Turbine engine components exposed to high temperatures generally may not be marked with A. Layout dye, commercial felt tip marker, or chalk. B. Wax, grease pencil, or a graphite lead pencil. C. Commercial felt tip marker or grease pencil. The correct answer is B. Turbine engine components that are exposed to high temperatures experience extreme heat and thermal cycling. Marking these components with materials such as wax, grease pencil, or a graphite lead pencil is not suitable because these materials can melt, burn, or transfer onto the surface, potentially causing contamination or damage to the components. 8139. Who establishes mandatory replacement times for critical components of turbine engines? A. The FAA. B. The component manufacturer. C. The engine manufacturer. The correct answer is C. The obligatory replacement intervals for important engine components are specified in the instructions for continued airworthiness, which were created by the engine manufacturer and authorized by the FAA. 8140. Main bearing oil seals used with turbine engines are usually what type? A. Labyrinth and or carbon rubbing. B. Teflon and synthetic rubber. C. Labyrinth and or silicone rubber. The correct answer is A. Main bearing oil seals are critical components in turbine engines that help prevent oil leakage and maintain proper lubrication within the engine. These seals are exposed to high temperatures, high speeds, and varying pressures, requiring them to have specific characteristics to perform effectively. Labyrinth seals are commonly used in turbine engines due to their ability to provide a reliable sealing effect. They consist of a series of closely spaced teeth or fins that create a tortuous path for the oil, reducing the likelihood of leakage. The design of labyrinth seals allows them to tolerate small amounts of axial and radial movement while still maintaining a sealing barrier. 8141. How does a dual axial flow compressor improve the efficiency of a turbojet engine? A. More turbine wheels can be used. B. Higher compression ratios can be obtained. C. The velocity of the air entering the combustion chamber is increased. The correct answer is B. In a turbojet engine, the compressor is responsible for compressing the incoming air before it enters the combustion chamber. The compression process increases the pressure and temperature of the air, which improves the efficiency of the engine. A dual axial flow compressor consists of two sets of compressor stages arranged in series, with each stage consisting of a row of rotor blades and a row of stator blades. This configuration allows for a more gradual increase in pressure as the air passes through each stage. By using a dual axial flow compressor, a higher overall compression ratio can be achieved compared to a single-stage compressor. The compression ratio is the ratio of the pressure at the outlet of the compressor to the pressure at the inlet. A higher compression ratio means that the air is compressed to a higher pressure, resulting in increased efficiency and improved engine performance.